Hi everyone. So in today's lecture we are going to discuss about the data types in Java. So today's topic is data types in Java. It is one of the important topics. So please concentrate here, right? So before going to the definition of data type, I would like to explain you the need of the data types. You know, the purpose of data types is to allocate sufficient amount of memory space to store data temporarily in computer through a program. It means allocates sufficient amount of memory space for the input of the program in the main memory, right? That is in RAM or in the JVM memory. So this is what the purpose of the data type. So in real world, we have different types of data. Like we have integer data, we have string data, we have floating point data, we have boolean data, we have character type data, right? So to store different type of data in program, we must use data types concept, right? So to store different types of data in program, we must use data type concepts. I can also say that the main purpose of data type is to define that what kind of value we can store into the variable. Okay, data type defines that what kind of value you are storing into the variable. Fine. For example, there is one variable of int type. It means that variable holds the int type of data, integer data. So, in Java applications, data types are able to provide following advantages. What are that advantages? See, we are able to identify the memory size to store data on the basis of data types. For example, if you, if you want to store int type of data, so the size of int is what, 4 bytes or 32 bits. So we are able to identify the memory size to store data on the basis of data types. Int is also a data type where the size is what, 4 bytes or 32 bits. The next advantage, we are able to identify the range values which we are going to assign to the variables on the basis of data types, right? For example, the range in the case of int is what? Minus int data type minus 2 1 4 7 4 8 3 6 4 8. Fine. Minimum value is this 2, max value 2 1 4 7 4 8 3 6 4 7. So this is what, if the data type is int, so this is the minimum value and this is the maximum value allowed. Fine. So we are able to identify the range value which are going to assign to the variables on the basis of data types. So any value between them or this also is allowed if the data type is what, int. Is it fine? Now let's see next. So basically data types are what? Data types are used to create variables by deciding what things, by deciding what type of values we are storing, okay, or what is the required size, or what is the range allowed. First question yourself before selecting the data type. You should you know decide based on these three questions that what kind of values we are storing, what is the required size, and what is the range allowed. Fine. You know, every variable has a type, every expression has a type, and all types are strictly defined. Moreover, every assignment should be checked by the compiler for the type compatibility. This is the reason Java language is also called as a strongly typed language. You know, so this is in the note section that every variable has a type, every expression has a type. For example, this is what the variable declaration and initialization, and I'm assigning this value to this a variable, right? So see, this a should have some data type. Here it is what, int. You can't write like a is equal to 10. You should first declare this with the help of what? Data type, that is int a. That this a is of what type? Int type. Then you can assign the value. It is perfectly 100% valid. Fine. And now see, this is what int result is equal to a plus 10. This is what assignment expressions. So see here, if in this case this a is of int type, so and 10 is also int here. Okay, so int plus int. Okay, is it fine? It will return you int only. So this result is also of int type. So it is 100% valid. What if this a is of double type? What if is this a is of double type? And if you are trying to perform a plus 10 in the case where a is double type, then it is not allowed because you are storing the value in the int type of result. So it is not allowed. Not allowed. You will get compile time error. Fine. You will get what? Compile time error. Fine. So hope this is clear. That is the reason, Java language is also called as a strongly typed language, because in Java it will check everything. Compiler will check everything. For example, compiler will check the what? That every expression has a type or not, or every variable has a type or not, and is it strictly defined? Is it properly defined? Right? Moreover, every assignment should be checked by the compiler for the type compatibility. Right? So now let's see the next one. So this data types are basically we have two types of data types in Java. What are the two types? First is primitive type, second one is reference type. So primitive type is used when you want to store single value at a time, and reference type is used to collect multiple values using primitive types. We will understand this, don't worry for now. So just for now, remember, basically we have two types of data types in Java. First one is primitive type, used to store single value at a time, and second one is reference type, used to collect multiple values using primitive types. Hold on, you should ask that already we have this primitive data type. Then what is the need of this reference data type? Why? Already we have this primitive, then why we are going towards the reference data type? See, if you declare a variable with primitive data type, then those variable will only allow to store single value, but never allow us to store multiple value of same data type. For example, see, I have declared this variable int a. I am assigning a is equal to 10. I am assigning one value. Remember, one value. This is perfectly valid. This is 100% what? Valid. Valid. Why it is valid? Because I'm trying to assign a single value. Single value in one variable. Single value. But see, in this case, it is what I'm trying to do. A is equal to 10, 20, 30. I'm trying to store multiple values into this primitive type variable, and that is not allowed. That is invalid. You can't do this. Fine? You can't do this thing. Because if you declare a variable with primitive data type, then those variable will only allow to store single value, but never allow us to store multiple values of same data type. See, this all are of same data type. Na? Int type of data it is 10, 20, 30. So if we want to store multiple values, what we have to do? What is the solution? If we want to store multiple values, then we have to create multiple variables. For example, here see. It is perfectly valid, right? We see this is invalid, right? So what is the solution? How can I make these things valid? See, so you have to create multiple variables. Like you have to create one variable int b and assign this 10, int c assign the 20, int d assign the 30, okay, int e assign this 40, and int f assign this 50, right? So this is one solution. And one more limitation here is we cannot store multiple values in continuous memory locations. For example, if I will use this approach, then what is the problem? This approach. Then another problem is what? See, let me show you the problem. We cannot store multiple values in continuous memory locations using primitive data type. This is the limitation. How? See, just now we see this approach like I'm declaring multiple variables to store multiple values. Okay, so int a is equal to 10, int b is equal to 20, int c is equal to 30, int d is equal to 40. So in this case, this is the memory location structure. See here, 10 is stored at this memory location, then 20 is at this, and 30 here, 40 here. So is it a continuous memory location storage? No. So we cannot store multiple values in continuous memory locations using this primitive data types. You can see properly here. It is not in a continuous fashion. It is in random fashion, right? So to overcome these limitations, we use another data type which is called as reference data type or derived data types. In every programming language, the concept of array comes under derived data type. Fine, because the solution is now the array here. Fine, now you have to see what the concept of array. Okay, now let's see the concept of array. What is array? What it will do? Derived data types are the predefined data types which are used to store multiple values of same type. Fine. For example, arrays. Arrays are one of the best example of derived data types because array will store fixed number of multiple values of same type in continuous memory location. Example, this is the example. See, here all the data are of what? Same type. Int, this is int type. And you are trying to store this into the int type of array. This is 100% perfectly valid. No doubt in this. Valid. See, arrays will store fixed number of multiple values of same type in continuous memory location. This is valid. Fine. Now the next example, I'm taking one more array. This is what? This is also an int type of array, that is b. I am trying to store, this is of int type data. Fine, but this is in double quotes. It means it is a string data. String data, int data, string data, again int data, int data. This is invalid. This is what? Invalid. Why it is invalid? Because these values are of different type. This is of int type, this is of a string type. So the values are of different type. This is why, this is the reason this is what? Invalid. Fine. Now let's see the internal things, how it will store in the memory. So 10, 20, 30, 40, it stores in the memory and it is of homogeneous type. Why I'm saying this homogeneous? Homogeneous means same type. So 10 is also int type, 20 is also int type, 30 is also int type, and 40 is also int type. That is why it is homogeneous type. Now see the location, memory location. It is continuous, right? It is continuous. For example, it is as 0th position, 1st, 2nd, and 3rd. It means it is in consecutive memory location. Fine. Or you can say it is in continuous memory location. Continuous memory location. So this is the advantage of what? Array. And the data were not stored in the consecutive or the continuous memory location in the case of primitive data type when we were declaring multiple variables in order to store multiple values. Fine. Now let's see the next concept. One thing, there is one more type, that is user defined data types. And user defined data types are defined by user or the programmer, which are used to store multiple values of different types. Till now we were storing the multiple values of same type, but we have one more data type which can store multiple values of different data types, and that data type is what? Classes. Our class. We will see this. Don't worry for now. We have this class, right? class. So for now, just remember this class can store the different types of values. Okay. So I'm creating an object of the class here. Okay. If you're not able to understand this, just leave it. No problem for now. I'm just showing this for means for the overview purpose, nothing else. Fine. So I'm creating an employee object here, and I'm assigning the value. This employee has some attributes, mean has some property, or has some variable declaration like emp id, ename, esal, and employee address. I'm storing the data. See, 10 is of what type? Int type here. Naveen is of what type? String type here. 3000. Salary is basically of double type, but okay, let us consider this is at double type itself. Okay, or you can say int type itself. No worries, because it is 3000. Na, int can hold this value, no problem. And emp address is of what type? Bangalore here, so it is of string type. So see, a class can hold a class. In the class type object, you can store different types of values like int, string, int or double, or string, or any types of data you can store in the object of the class. Okay, fine, that you have stored here. And this e holds the address of the object. This e basically holds the address of the object. Address. Okay, it means this e is pointing to this object, and this object is created in which area? Heap area. Heap is a memory area in the JVM. Don't worry, we will discuss each and everything. Fine. So this thing is clear. This is one another data type, that is user defined data type. The agenda is clear. Now let's see the next and the last one. You know, also let me cover one more thing here. Fine. So suppose this is client computer and the server computer is present somewhere else, and I want to send this data. For example, this value, this value, this value, this value, up to 10 values I have. So also using variables, we cannot pass all the values to the remote server computer, right? With single network call. What do you mean by network call? Means over the internet, because this is present somewhere else, this is present somewhere else, and this is present somewhere else. I want to send the data. So to send this, one network call is required. Means I have to send this data over the internet by the help of the internet to this server computer, right? Again, for sending this data also, I have to make another network call. For sending this data also, I have to make another call. For this also another call. Like this, I have to make 10 calls, 10 network calls in this case, right? 10 network calls. So tell me one thing. So using variables, we cannot pass all values to the remote computer server right here with the single network call. Right here multiple network call is required, which increases this multiple network call, increases burden on the network, and also increases line of code in the program. Also increases line of code in the program, right? In the program. So to pass this 10 values, it consumes 10 network calls. Another problem with the primitive data type. This is what the another problem with the primitive data type, because this all values are stored in the primitive data types like int a is equal to this, int b is equal to this, int c is equal to this. So all this value we have to pass one by one using the network call, using different network calls. For example, here 10 network call is required to pass this 10 value. Suppose we have 100 values, then 100 network calls are required. That is not a good thing, no? It increases the burden on the network and also increase the line of code in the program. So to overcome this thing, to overcome from this problem, we have the arrays also, and we have the classes also. This is another disadvantage of what? Primitive data type, right? This disadvantage. This is disadvantage itself. Earlier we saw one more limitation, that is it is not storing the value in the continuous fashion in the memory, right? And this is the second limitation. So this all are the reason we are using the arrays or we are using this classes, right? And in the further lectures we will see about the collections also. I will cover each and everything, don't worry. So in the next lecture we will see primitive data types in detail. So thanks for your valuable time. Please subscribe our YouTube channel.